Evening. Today we will see the design details, or we can say better detailing of reinforcement, and that we are going to see as per SP34. So actually, whatever we have done, that is according to SP34. Otherwise, in examination, if examiner asked you, "Do you know SP34?" then you can say, "We do not know SP34." So we have actually not gone through this SP, Handbook of Reinforced Concrete and Detailing, that is Bureau of Indian Standard. And you can see here it is written as SP34. And this is Handbook of Concrete Reinforced and Detailing. And if you will go to your syllabus, in syllabus they have mentioned two codes. One is SP34 and another code that is 13920. I don't remember exactly, but 1392 likewise something. But this is for earthquake engineering. You can go to your syllabus. So just I will go and I will exactly tell you. That is Indian standard we have. So just a minute. So let us, I will mention that one till that we will go. Now you can see this we have first. So the just I got it. Yes, 13920. This is correct. So this is for earthquake, considering earthquake, and so we have not used this one. But whatever detailing we have done, that is by using SP34 only. So this now I am going with that one. Now you can see this reinforcement. So let us, we have, this will be one way slab. So we have this as one way slab. So now you can mention a typical details of a slab spanning in one direction. This diagram is in SP34. Keep in mind. So this most important one. Now, otherwise you will say that we do not know SP34. So all details are as per you. You have drawn this diagram for INSEM examination, if you remember. And then you can see we have this value where we are going to bend. When we have discontinuous support, if you remember it, then we have that is at 0.1 L. So you can see here, this is from here. So you can have, this will be 0.5 AST. So that means 50% we are going to bend and 50% will continue, or 50% we are going to curtail, and top we are going to provide this reinforcement. So this we are going to curtail. So here you can see this is given. So this we are going to, bottom we are going to be from center, and top we are going to be from face of the column. Now here we have simply supported. So you can see alternate. First this bar we have bent up on this side. So second bar we have bent up on this side. So bar bent up on this side is straight on other side, and bar bent up on this side is straight on other side. So that is shown over here in your SP34. This same we have used. Then in other direction you can say, or we can say it is two-way slab. So last we have seen one-way slab. Now we have that two-way slab. In two-way slab, main reinforcement we have on both the sides, whereas in one-way slab we have main reinforcement on one side. So one side we have main reinforcement. Main reinforcement is always on bottom. So whatever dotted are shown, they have mentioned over here. You can see this. So why this is one way? Because another we have distributed bars which are dotted, and main reinforcement we have at bottom. So this is one way side, one way slab. And then we have this as two way slab where we have main reinforcement on both sides. So along shorter direction reinforcement we have bottom. So shorter is on bottom side and longer we have on upper side. Shorter is bottom side. Reinforcement along shorter is on bottom side. And then how much distance we have to consider. You can see where we have to take this. So you have to take this, that is LD by 3 inside. What is LD? Development length. Now formula we know. I will not go in detail with that one. So you can see here, this is from center. So we should know this 50% only we can curtail or bend, and 50% we are going to be inside the support. So curtailment or bent up is only 50%. So you can see along Y direction we have 0.1 Ly. Along X direction we have 0.1 Lx, from where we are going to bend it. So that you have to keep in mind. In slab we are going to bend the bars at 0.1 L from both. And these are sections shown. If in examination, in oral, if that is shown, show your slab reinforcement two-way and show section of one side. So you should be in position to show that section. So here these are reinforcements. So clearly mentioned. So we should know how we have this reinforcement and how we are going to plot these sections. Then we can see this is continuous. So that is mentioned over here. So all these, keep in mind, we are drawn in the same fashion. Now these are given in SP34. Now you can see this. So we have same way. We have at continuous edge, we have curtailed at 0.25 L1. On this side, we have span as L2. So we have curtailed at 0.25 L2. So these circle will show that till this. Here you can see beyond this. So whatever this, we have 50% remained. And here we have AST. You can see here we have AST. And when you will go towards support in 0.25 L1, so it will be 50% we have curtailed. Or you can have bent up this 50%. So you can see on discontinuous edge. So you have this value 0.15 L1. You have gone through all these. You have shown in the same fashion. You have to tell is this is SP34. You have to keep in mind this part. Now here you can see alternate bars. You can see 0.3 L1. So you can see 0.3 L1 and 0.15 L1. You can see in this, you have AST2, means you have both bars which are of length 0.3 L1 and which are of length 0.15 L1. But after this 0.15 L1, we have only 50%, 0.5 AST2. Means 50% steel, means all steel we have in this 0.15 L1 and only 50% we have on this, because whichever is 0.15 we have like this, whichever is 0.3 L, it is in 0.15 also, and beyond that we have 0.3. So this will be AST, and here you have 50%. So this becomes 0.5 AST. So they have mentioned here 0.5 AST. Now you can see on top side or at support, you can say at support at top, we have these values from face of the support. We have this from face of the support. They have clearly mentioned values beyond face of the support. And in case of bottom, you can see these are from center. So you can see over here also, these are from center of the support values, 0.15 Lv. So that you should be in position to answer the values very properly. Now, why we are providing this reinforcement at top in at support? Because we have, you should be in position to draw this bending moment diagram. So we have bending moment diagram in this fashion. So at support, we have tension at top, and in span, we have tension at bottom. So in this region, tension is at bottom. Therefore, we have provided reinforcement at bottom. So this is reinforcement provided at bottom. Now here we have tension at support, we have tension at top, and therefore we have provided this reinforcement at top. Same in the fashion. So this is BMD for continuous beam. You should be in position to draw this BMD, and then you should be in position to answer the question or draw the reinforcement. So same that is given below. You can see B using straight bar. So what is difference between these two diagrams? Here they have used A part, that is using bent up bars. You can see this. So using bent up bars, and here using straight bars, means here we do not have bent up bars. What does it mean? No bent up bars. So we do not have bent up bars. So here we have reinforcement at top and reinforcement at bottom, we have separate. And therefore here you can see these hook shows you have curtailed these bars. You have cut these bars. So these are showing. So you can see 0.15L, 0.15L1, 15L2. These bars 0.3L1. So these are till end. So these are curtailed. Here you can see 0.25L2 curtailed. Here you can see 0.15L1 curtailed. Here you can see 0.1L1, which we have seen in slab. So at the top we have 0.1L1. At bottom, we have 0.15 L1. So we should be in position. So beyond face of the column 0.1 L1, which we have already seen in slab also. That is upward portion we should have. Actually, this we have 0.1 L1. So this we should know very properly. So you should have to draw these diagrams in oral. So generally, you have one question. You have to write down the steps, that is of design of, it may be slab, one-way slab, two-way slab. Then second, you have design of beams. Then you have design of columns. Then you have design of footing, and then you have design of staircase. So out of these 5 or 6, you have to write down steps for one of these. Second question you may have given, so show the clauses of T-beam. Now we have clauses of T-beam. We have two. One, when beam will act as T-beam, if my main reinforcement of slab is perpendicular to the span, it will act as T-beam. Or if it is parallel to the span of beam, then it will act as rectangular beam. Then to act it as T-beam, we have to provide transverse reinforcement as 60% of main. So likewise, you have questions in this one. You may have question that show the bending moment coefficients for continuous beam, and what are the clauses for it, or when we are going to use these coefficients. Then we should be in position to answer. We require minimum 3 spans. The span should be within, value of the span should be within 15% of it. So likewise, you should be in position to answer the questions about the clauses. You need not require to mug up the clauses, but whenever you have asked shear reinforcement, then you have to show shear reinforcement, that is minimum shear reinforcement, and then design shear reinforcement. You should be in position to write the formula for spacing of minimum shear reinforcement and spacing of design shear reinforcement. Likewise, we have to go. Now you can see this is given. Actually, we have not used simplified curtain rules for continuous beam. So they have mentioned here 0.15 L, 0.15. So we have not seen this one. So do not tell about this one. Whatever before that we have seen, that you have to answer. Now you can see this is SP 34 1987. So you can tell that we have used SP 34 for detailing of reinforcement. So this is staircase. Now I already mentioned, you can see whatever this bar is not coming down, this bar is going up. Because why it is going up? When we will make it straight, then we have sufficient concrete below it, and concrete will not crack. If I will take this in this fashion, then what will happen? So we have concrete over here. When it will try to become straight, then we have only cover, and this cover may crush. Concrete may crush of this cover, and your reinforcement may expose to environment, and it may corrode, which will reduce its strength. So this bar, now you can see this bar we have not taken below. So this bar I will say we have not taken this bar below, because if we will take this below, then if it will try to become straight, then again you should have only cover over here. Now you can see if it will become try to become straight, then it will become straight, and you have this portion over here. And then it will not crush the concrete. And likewise, here also you can see we have not taken this directly here. Because if we will take, then again, if it will try to bend, then it will crush the concrete. So this reinforcement is most important in your dog-legged staircase. And we should know loading, if we will say, then on landing, we have loading that is a slab only. First, we have that is self weight of slab, which is 25D. What is 25? 25 is unit weight of concrete. 25 unit weight of concrete. And then what is unit of this? Kilonewton per meter cube. Then we have second, floor finish. These are the two dead loads. And then we have third is live load, or we can say live load. So we have these loads when we will say as landing. If I will say what are the loads ongoing, then ongoing we have first self weight of slab. Now what is formula? So we have 25D sec of phi. And now what is sec of phi? So we have sec of phi is equal to root of r square plus t square upon t. Now how this comes, that already I explained in the class. You can go through this, and this value is always greater than 1. Then second we have weight of stair. This we are going to take 1.5 r. 25 into 1.5 r. So that is for your self weight of step. Self weight of step. Then third we have, then same floor finish we have. And then we have live load. So change we have here, this comes sec phi. And here we have that is weight of step. 25 r by 2. So that we have to add, and therefore, if you will go for first flight, then for first flight, we have values in this fashion. So first we have that is going, this portion we have going, and remaining portion we have landing. So landing value is always less of load, so we are being in this fashion. And here we have to find out zero shear force, and then we have to find bending moment. If I will go, then second we have over here, this is intermediate flight. And intermediate flight, we have diagram in this fashion, that is uniform. And then we have landing on both sides, and then middle we have going. And then we have maximum bending moment at center. If we will go for open newel, so what is difference? So whatever value of load on landing we have calculated, load on landing, we have to consider half load on landing, half of the calculated load. Why? So already I explained, you can go to your notebook, because if I will draw this diagram, then we have diagram in this fashion. So we have 3 goings over here. So we are in this fashion. One will be on this. So like this. Then this landing. Then this steps. And then we have this landing and this step. So this landing is common to these two. So half will be taken by this flight. Half will be taken by this flight. Similarly here, half will be taken by this flight, half will be taken by this flight. And therefore we have landing value will be half the calculated. Calculation we are same, whatever we have dog leg, but value we have to consider half of that value. So here also you can see, this will be continue, because if it will try to become straight, then it will be in this way. And then we have here sufficient cover. So whatever concrete we have, because when it will try to become straight, it will apply force on this side. So here you can see that was taken on top. So if it will try to become straight, then we have sufficient value over here. If it will be taken down, then we have only this portion where force will be applied to become straight. And therefore we have taken this value. Now sometimes you may ask, what will be this length beyond this? So we have beyond this, we can have LD, development length. How we will calculate this? That you should know. These all diagrams are from SP 34. So keep in mind. So whatever detailing we have done, we have that detailing as per SP34. You have to keep in mind this. So now these are main reinforcement, and then you have to show distribution reinforcement over here. That also you have to keep in mind. Then we have this minimum 2 bars I already mentioned, that is shown over here, and that they have simplified, they have considered. So you need not require to go for this. But in bars, in beams, you have to say minimum 2 bars, and that is of 12 torque. Why? This is for shear reinforcement. Now, where we have shear reinforcement, that already I explained. So likewise, you have to go for this detailing of reinforcement. Keep in mind, this detailing of reinforcement is as per SP34. You can download and you can just go through that SP34. So you will be confident about the detailing we have done according to SP34. So now I will stop here only. Thank you.